Day 14 of 90, and we're building something you actually understand, a student grade system. Sounds like a beginner toy, right? But this is the exact muscle you'll use for order, line item, and invoice in every real .NET backend you ever touch. Watch the finished output first, a console table of ranked students, each with their average and a letter grade, sorted highest to lowest. By the end of these 5 minutes you'll build that in layers, and you'll see why records, LANQ, and pure methods make this clean instead of a tangle of loops. Most people stall here. You can write a for each loop and an if statement in your sleep, but the moment someone says organize this into classes, you freeze. Do I use a list or a dictionary? How do I average without a manual accumulator? Let's kill that hesitation. Step 1. Model the domain with types, not loose data. We define a record for a grade, public record grade, string subject, double score, and a student, public record student, int ID, string name, list grade grades. Records give you value equality for free, 2 grades with the same subject and score are equal, no boilerplate. Why a record over a class here? Because grade is data, it has no behavior, it's just a value you pass around. Records communicate that intent and they're immutable by default, so nobody mutates a score behind your back. Now the gradebook. It holds private read-only list grade underscore grades equals new, and exposes an add method. Notice it's a list, not a dictionary keyed by student ID. The TikTok trap is real, a dictionary keyed by ID silently overwrites when 2 students collide. A list plus a first-or default guard never loses data. Here's where LINQ earns its keep. Instead of nested for each loops with running totals, we write one query. Students, select, s equals new grade report, s.name, s.grades average, g equals g.score, s.grades max, g equals g.score, s.grades min, g equals g.score. One line replaces 15. Want per subject breakdowns across everyone? Grades.group by, g equals g.subject, select, group equals new, subject equals group key, average equals group average, g equals g.score. Group by is the loop you were about to write by hand, average, max, and min are the accumulators you were about to declare. Let the library do it. Now decompose. The mistake is cramming calculation into the gradebook. Instead, extract a grade calculator static class with pure methods, no state, just input to output. Public static char letter grade, double average, equals average switch, equals 90 equals A, equals 80 equals B, equals 70 equals C, equals 60 equals D, underscore equals F. Add is passing all, enumerable grade grades, returning grades all, G equals G.score equals 60. Pure static methods are trivially testable, no object to construct, no state to arrange. An X-unit test is one line, assert equal, B, grade calculator.lettergrade, 85. That's the payoff of single responsibility. Each method now has one reason to change. Parsing changes? Touch the parser. Grade thresholds change? Touch the calculator. Display changes? Touch the renderer. They don't bleed into each other. And the parsing boundary matters most. Read CSV lines into grade objects with a static factory, grade parse, \math 87 \, that splits, validates, and throws argument exception, \score out of range \, on bad input. Validate at the boundary, and the rest of your system never sees a raw string. Every downstream method trusts its inputs because the edge already checked them. Finally, rank and render. Students.order by descending, s equals s.grades average, g equals g.score, gives you the leaderboard. The renderer just walks that ordered list and prints rows. And here's the separation paying off immediately. Swap the console renderer for a string builder that emits HTML or CSV, and you change exactly one class. The calculation, the parsing, the model all untouched. That's not over-engineering for a grade system. That's the same boundary that lets a real service add weighted grades next sprint without a rewrite. So today, records for your domain, a list with guarded lookups, LANQ group by and average instead of manual loops, and pure. Static helpers you can test in one line. Build the grade system yourself, then notice it secretly an order system, an invoice system, every domain you'll model. Types are your first design tool. Day 14 done. Subscribe for day 15.